Guys, so today we're finishing up the review sheet. So today we are finishing up the review sheet, and so since we're not going to be here tomorrow, we can't take the test tomorrow. And since we're not going to be here Thursday, we can't take the test Thursday, so we're going to be taking the test on Friday for over this here, okay? Now, we've covered most of it so far. We've gotten up to, we're going over the review. So we went over these three here Friday.
I was talking to my chef.
I've got a few. I got Eric bringing 3 copies of the review sheet down.
Okay. Yeah, I have it in my truck.
Yeah, So we finished, I believe, on 21. We finished it up, but we can look at it again. Now with the special right triangles, we have the properties. So for the 45, 45, 90. 45, 45, 90 special right triangles. Well, the sides opposite the 45 degrees are the same. They're going to be the same, and the hypotenuse is whatever that value is times square root of 2. So if we're given either leg, the sides opposite the 45, our legs, if we're given the legs to start with, to find the hypotenuse, we take the value of a leg and multiply it by the square root of 2 to get the hypotenuse, because the two sides would be the same. Now, if we're given the hypotenuse to start with, we take, to find the leg, we take the hypotenuse's value and divide it by square root of 2. Then we get back to the legs. Now, for the 30, 60, 90 right triangles, there's different setups that we can have. The first one starting out with the short side length. Because if we're given the short side length to start with, we can take the short and multiply it by 2 to get to the hypotenuse. And to get to the long side length, we can take the short side length and multiply it by the square root of 3. Now, if we're given the long side length to start with, the first side we want to get back to is the short. And we can get to it by taking the long side length and dividing it by the square root of 3. And then finding the hypotenuse by multiplying the short side length by 2. And the last setup that we could have is if we were given the hypotenuse to start with. And if we're given the hypotenuse to start with, we want to get back to the short side length first, which is taking the hypotenuse and dividing it by 2. And to find the long side length, we multiply the short side length by the square root of 3. And we had these kind of shortcuts to get there, but we could also use sine, cosine, and tangent. So if we're looking at number 21, this here is a 45, 45, 90. So the sides opposite the 45 degrees are the same. And it also lets me know that 4 is the hypotenuse because it's opposite the right angle. So x and y are both going to be the same. Now, using the shortcuts, we know that we can find this by taking 4 and dividing it by the square root of 2. And if we type this into the calculator, we would get 2 square root of 2. So it tells us that x and y would be 2 square root of 2, and we'd be done. Any questions on this so far? Now, if we're don't feel too comfortable doing that, we could use sine and cosine. Now, since I'm wanting to find the hypotenuse, we're going to have to use sine or cosine. Because tangent is opposite over adjacent. Since we're given the hypotenuse, we need to find or use one of them that uses the hypotenuse. Now, sine of an angle is the opposite side length over the hypotenuse. In this case here, the hypotenuse is 4. Now, we could say that the opposite side is x. If we do that, that means we're using this angle down here. Or if we said the opposite side is y, well, it would be this angle up here. But what do we know about x and y in a 45, 45, 90? For this here, they're going to be the same. So at this point here, we can multiply both sides by 4, which will tell me that 4 times sine of 45 degrees equals x. It would be, and at this point here, we can type 4 sine of 45 into the calculator, and if we hit enter, we get 2 squared of 2. And that'd be it. That'd be the answer for both sides. Any questions on this one here? Okay. Now, if we look at the next one, I'm going to erase this here. We have a 30, 60, 90 right triangle, yes? And are we given the short, long, or the hypotenuse? The hypotenuse. But according to our shortcuts, to get back to the short side, we take the hypotenuse and divide it by 2, and 14 divided by 2 is 7. And the side opposite 30 degrees would be the short side, which would be our y. Y would be 7. Now, to get from the short to the long, we take the short side length and multiply it by, which would be 7 square root of, and that'd be x. And that's all we would have to do for this here, just following the shortcuts that we have for the 30, 60, 90. Well, again, we can do what we just did with sine, cosine, or tangent. So if I wanted to take cosine of 30 degrees, well, cosine is adjacent over the hypotenuse. Our adjacent side for 30 degrees would be x, and the hypotenuse would be our 14. Well, to solve this here, we would multiply both sides by the bottom of the fraction. Multiply both sides by 14, so these will cancel, telling us 14 cosine of 30 is equal to x. Well, at this, and that's what we got doing it the other way. Well, at this point here, we can use sine or cosine to find the other one, or we could actually use the Pythagorean Theorem. Because the Pythagorean Theorem, we need it to be a right triangle, which we have, and 2 side lengths. Well, I have that now. So if I wanted to, we could say 7 square root of 3 squared plus y squared is equal to 14 squared. Now we can do 7 square root of 3 squared, and if you type that into a calculator, you'll need the parentheses. So we can say 7 second square root 3 squared. We get 147. We also have 14 squared, which is 196. So that's telling us 146 and 196. Yes. 147. So this should be 147. Well, at this point here, we can subtract 147 from both sides, telling us that y squared is equal to 49. Square root both sides tells us y is equal to, which are the exact same values we found by doing the shortcut. So either method works, defining it. It's just figuring out which one that y'all want to do better, which one you prefer. Any other questions on 21 or 22? Questions on 23? Because again, it's using those same methods. We can either use the shortcuts to get it, or we can use the Pythagorean Theorem once we get one of the side lengths. So looking at this here, well, we're given the side opposite 60, so it's the long side. So to get back to the short side, we take 6 and divide it by square root of 3. 6 divided by the square root of 3 works out to be 2 square root of 3. And to get to the hypotenuse, we take the short side length and multiply it by 2, which gives us 4 square root of. And we could have used sine, cosine, and tangent and gotten to the same thing. Any other questions on this here? So we do have other examples with those there, but they're just the exact same thing. So if the shortcuts are a little bit confusing, we can use sine, cosine, tangent to find the missing side lengths. Well, looking at 28 and 29, find sine, cosine, and tangent as a fraction of each acute angle. So there are two acute angles. One of them is A, and the other is C. The only one we won't be finding is the 90-degree angle, whichever one's the right angle. Now for all of these here, sine, okay, apparently I'm just going to scroll. Sine of an angle is opposite over the hypotenuse. Sine is opposite over the hypotenuse. Tangent is opposite over the adjacent. So for angle A, the opposite side length would be 65. The hypotenuse would be 97. Now sine of C over here, the opposite side is 72, and the hypotenuse is still 97. Now cosine of an angle is the adjacent side over the hypotenuse. So cosine of A, well, the adjacent side to A is 72 over 97. Cosine of C, well, now the adjacent side is 65 over 97, because opposite and adjacent is all based off the angle that we're looking at, or looking from. And lastly, tangent of an angle is our opposite side over the adjacent. So tangent of A, well, the opposite side length of A is 65, and the adjacent is 72. Tangent of C, now the opposite side is 72, and the adjacent is 72. And that's all it's asking for this here. It's just wanting it as a fraction. And it doesn't ask for decimal, it just wanted fraction. Don't have to reduce it. That's it. Any other questions on these here? Yep. Yeah, we'll take it on Friday. Yep. Most likely, y'all can get probably all of it done in one day, if y'all want to. Especially these here. I think these here are going to be some of the ones y'all would want. 41. So it's not too bad. And especially with these here. Yeah, because I split, I think, the special rights and some of those solving to the second part and have everything else in the first. Now these here, I think y'all would prefer having the entire test. Yeah. Tangent of 49.8. Tangent of 49.8. Enter. 1.1833. 1.1833. That's it. The next one is sine of 61.72. So we can grab the calculator and say sine 61.72 and hit enter. 0.8806. So on these here, evaluate and round to 4 decimal places, that's all we're doing. We're just plugging it in. We can do the same thing with 32, 33, 34, and 35. We're just plugging them in. Any other questions on these here? All right. Well, here it wants us to what? Write sine as, or cosine as sine. Yep. So if we're given sine of A, we're rewriting as cosine of 90 minus whatever that angle is. And that would give us our answer. Now, if we're given cosine, well, cosine of A is equal to sine of minus A. Now, for our first one here, we have sine of 67. So our answer is going to have cosine of an angle. Yes. Because what we're taking and doing here is cosine of 90 minus 67. Well, 90 minus 67 is 23. So that's the answer. We're not actually finding or evaluating for each one. We're just rewriting sine as cosine or cosine as sine. Well, that means for number 37, since we start out with cosine, our answer is going to be in terms of sine. So here we're going to have sine of 90 minus 3.2. 0.86. I believe it should be 86.8. 90 minus 3.2. We have it in this here. I mean, we could keep doing this here. So the next one is sine of 2. We'd have cosine of, well, yeah, 90 minus 2 would give us 88. So the answer is cosine of 88. And that's all we have to do for this here. Any questions on these here? 41, 42. So evaluate, find the exact value of each expression. Sine inverse of sine of 81. Second, sine inverse of sine of 81. And I mean, we could type these straight into the calculator and it would give us an answer. For these here, most of the time, yes. Because as long as the angle that we have inside here is between 0 and 90, or negative 90 and 90 for sine, 0 to 180 for cosine, and negative 90 to 90 for tangent, then it works out quite well. Once we get outside of the range, it's a little bit more tricky. But all the ones that we'll be looking at are going to stay between 0 and 90. Find the exact value of angle A. Well, to undo sine, cosine, or tangent, we need its inverse. So for the first one here, if I apply sine inverse to both sides, well, sine and sine inverse will telling me A is equal to sine inverse of 0.7436. 0.7436. So I can grab the calculator and say second sine inverse 0.7436. 48.03 or 48.04. Three or 04 because 38. That's it. So really we're just taking the inverse of the other side. Now for 46, which function would we be using? Inverse, cosine inverse. This cosine and cosine inverse would cancel, telling us A is equal to sine inverse of 0.3496. And again, we can grab the calculator and say second cosine inverse of 0.3496, 69.54. And that's it. Questions on these here? So, so really the next one, 47, I can say what? A is equal to tangent inverse of 0.9874. Type that into the calculator. $44.64. That's all we need to do for this here. Any questions on any of these here? Okay. All right, 51 through 56, because I don't think we have too many more sets left. Okay, now looking at all these here, we're going to either use sine, cosine, or tangent to solve. We're going to use sine if we're given the opposite side and the hypotenuse. We're going to use cosine if we're given the adjacent side and the hypotenuse. And we're going to use tangent if we're given the opposite side and the adjacent. So depending on what we're given is going to be which one we use, sine, cosine, or tangent. Now looking at the first problem here, 51, well the angle they gave us is 36. So we need to determine if we're using sine, cosine, or tangent. Cosine. One of the reasons we know cosine is because 27 is the hypotenuse. Well, for sine or cosine, the hypotenuse is always in the denominator. Now, the other side that we're looking for has x, and is it adjacent to or opposite that angle? It's adjacent, so we would use cosine. So cosine of 36 is equal to x over 27. Now that we have that set up, the first thing we'll do is multiply both sides by the bottom of the fraction. So we'll be multiplying both sides by 27, which would tell us that, guys, 27 cosine of 36 is equal to x. And at this point, we can plug it into the calculator, which would give us 21.8435. If you guys want to go 2 decimal places or 4, either one works. And that's all we'd have to do for this here. Any other questions on 51? Any questions on 52? Because with any of these here, if we multiply or divide, or we multiply by the bottom of the fraction and x isn't by itself, then we have to divide. For 52, well, we're going to end up using cosine of 56, because they give us the adjacent side of 17, and we're solving for the hypotenuse. So we're still using cosine. Now for this one here, we would multiply both sides by x minus x cosine of 56 is equal to 17. But here, x is not by itself. So we would have to divide both sides by cosine of 56. These will cancel, Now at this point here, we can plug in 17 divided by cosine of 56 into the calculator, which would give us four something or three something, and that'd be our answer. Any other questions on 53, 54, 55, 56? Because again, these are just using sine, cosine, or tangent based off of what we're given. All right. Let's look at 57 and 58. These are the last types that we have. Now, this here we're trying to find the hypotenuse or one of the side lengths, because 57 is the hypotenuse, and then the two angles. Now to find the hypotenuse, well, we can use Pythagorean theorem. A squared plus b squared is equal to c squared. Well, the value of a and b in this case is 20, 15, and c is our x. Now, 20 squared plus 15 squared is 625. And I know that because we did this first or second hour today, so. And we could have plugged that in a calculator all at once. Now we're going to square root both sides. And it tells us x is 25. All right, so any questions on how we found the missing side lengths? Okay. Now, at this point here, we're going to need to find one of the angles, and we're going to be using our tangent inverse, sine inverse, or cosine inverse. Well, we have all three side lengths, yes? So does it matter which one that we use? No. So if I pick, say, tangent of x, angle x, well, that's opposite over the adjacent. So the opposite side for angle x is 20. The adjacent side is 15. At this point here, we can use our tangent inverse of both sides. These here will cancel, telling us that x is equal to tangent inverse of 20 over 15. And at this point here, we just need to type this into the calculator, which for 57 would give us that x is 53.1. Well, we know that any three angles in a triangle add up to be 180. And if it's a right triangle, the two acute angles add up to be 90. So we can actually subtract 53.1 from 90, which will give us 36.9 as y. And that's all we'd have to do for this here. Any questions on these here? Do we have any questions on 58? Because the only thing that would change for 58 is that we're solving for a side length instead of the hypotenuse. Do we want to see this one work?
Yes.
Okay. Now for this one here, we're going to start off by using the Pythagorean theorem. A squared plus b squared is equal to c squared. Now, c, our hypotenuse, is given as 65. We don't know b squared, but we know a is 36 squared. Now 36 squared, if we plug that into the calculator, we get you're good. Then we can also do the same thing for 65 squared is, it's going to be a big number. We can plug those into the calculator and get them. Now we do need to get b by itself, so we would subtract 1,296 from both sides, because these would cancel. Lily, face forward. So it works out that it's 2929. Then we would square root both sides, telling us B is approximately, or yeah, the missing side length 54.12. On the answer key, I stopped at 1 decimal place, so that's fine. 54.12 or 54.1. I will take either 1 or 0.12. Either one works. They're the same number. Then from here, we need to find the missing angle. So we can use sine, cosine, or tangent. It doesn't matter which one we use. So we can say cosine of y. I like using this one here specifically. I would either use sine of x or cosine of y, because cosine of y is going to be adjacent over the hypotenuse. I'm using the two side lengths that we didn't have to approximate for the decimal. And again, here we would use our cosine inverse of both sides, telling us y is equal to cosine inverse of 36 over 65. And it would jump like that. And it's telling us that y is equal to 56.4. And if we subtract that from 90, we get 33.6 for the other angle. Yep. So really, to get the other one, we're taking 90 minus 56.4. So I didn't write the cosine inverse on that one, but we would still be applying it to both sides to get to the answer. Any other questions on any of this here? And that's it. So your test, if we are here Friday, your test will be on Friday. If we're not, test will be on Monday.